So I'm Daryl Chastain. I'm a PhD in crop and soil sciences from University of Georgia. I'm 33, I believe. How many years in this field? I have been here since 2015. I've been working in cotton since 2010, I believe. And Here at at Mississippi State University, I am a cotton systems agronomist. The system means like anything cotton. So literally, I do everything cotton. So we look at one particular problem. It's reniform nematode. It's Rhodolenchulus reniformis. I have to look at it every time I read it, but every time I say it. But it's a widely distributed pest that it's a little worm. This little worm here. It lives in the soil, a particular soil type. It just so happens that this particular soil type is where cotton grows really well. Okay? It is widely dispersed across the South. If you look at the green on the maps here, that's the state of Mississippi. The green is where reniform nematode is. And if you look at the big map over here, I guess it's the smaller of the southeast, where the dark green is, that's where reniform nematode is. That bottom map is cotton production all over the entire United States. It just so happens that it overlaps a lot of the same areas. And it causes about an 8 to 10% yield loss, so it's a lot of money. When you're looking at millions of acres of cotton, 8 to 10% yield loss is a big problem. But we're in Mississippi that haven't been able to plant cotton for 20 years because reniform nematode is so severe that they have to plant another crop. Most of my research focuses on, I have a PhD at Georgia as well. Most of my research focuses on a mechanism to cause a yield loss under a stress. Two general categories. Well, first of all, I guess my research goes on in the Mississippi Delta. Since you're not from here, it's the almond shape on the screen. So my research focuses on two categories. We have abiotic stress, so it's the environment, so heat, drought, cold, any abiotic factor that can result in a yield loss. And I quantify metabolic changes in response to these stressors. So most of my work has been in drought for my PhD work, and I'm breaking into flooding now, which can cause similar response to drought. And you know, it's a huge problem across the U.S. The dark green on the bottom states there, that's our cotton production region. And I think that this was a drought during the summer of 2014 or 2013, I can't remember. But it pretty much hit every single production region. So you had a yield limitation right during the critical period of flowering. And that gave me a lot of funding, basically. But since I've been here, I've been doing a lot of biotic stress, so how pests or disease or anything like that, anything biological can cause a yield limitation. So whiteflies, bollworms, weeds down here in the bottom corner. Other things can be a little bit harder to pick up. You can just notice there's symptoms across the field, but you don't really know what's causing the problem. It could be in the soil, it could be a bacteria on the leaf, it could be a heat stress, or there could be a different soil type there that's causing a water limitation. So I'm the guy that comes in and helps out with that sort of thing. Typical equipment we use doesn't really show up very well on the screen, but that top machine is a portable photosynthesis system. I can measure water vapor and carbon dioxide effectively, but based on how I set up the environment and what conditions I expose the plant to, I can gain a lot of information on their base metabolism. And then get information on those factors in response to a stress and gain basic knowledge about how plants function, not just cotton specific, but any crop. We have a lot of fancy equipment. The top piece is about 50 grand, bottom piece is about 60 grand, and the bottom one we can measure individual metabolites and gain even more information, learning how these pathways change in response to a stressor. We carry a lot of big heavy equipment out in the field. This top left can give me an indication of water status. So basically it uses compressed nitrogen to tell you how stressed each individual plant is. We use a lot of temperature sensors because if a plant's under water stress, the leaf tends to be hotter, and that gives us a lot of information about how a crop's performing. We can use that information to fly a drone over and, get all this, one swipe you can get an entire field. The one on the bottom left gives me a lot of information on how light is being captured by the plant. Very, very sensitive processes. If you have certain biological or even like a pesticide, it comes in, it can change the parameters that I can measure off of this machine. It's all non-destructive too, so it doesn't harm your crop when you sample. But really most of the work that I do is I look at changes in growth, how well the plant is growing, how big the plant is getting over time. So we spend day after day after day after day sitting on a chair, pulling leaves off a cotton plant and running it over a conveyor, counting leaves and getting how big they are. So it seems like boring work, but it's really good data. We also collect a ton of environmental data. This pressure chamber, again, a lot of the work we'll do, you'll go out dawn, like before dawn, and carry this 40-pound machine across the field with you and sample plot after plot after plot. And it's fun. But we're getting ways around these direct measures of plant water status to get indirect measures based on like weather parameters like humidity and temperature. And then we can use these factors from these little weather stations here along with soil moisture sensors that are in the ground and maybe cut a little bit of that groundwork out so farmers can make decisions based off of sensors. But these indirect measures, like this sensor down here measures leaf canopy temperature. And it seems like a great, wonderful answer for this solution, for this problem, and allows producers to decide when they're going to irrigate their crop, but you never really know what's going to happen. In one of our studies, our sensors were really attracted to bees. So we had bees on all of our sensors, and the bees would trigger irrigation events, and that was problematic. So, I mean, seriously, it was fun. And to be the guy that has to get the bees off of your irrigation sensors, so it was fun. But Cotton Incorporated like represents our interest as an industry. They fund research both on the state and regional level. So you submit a proposal to them, and they have a board that decides whether or not your research, typically it's on the state, you'll have producers, and the producers will determine whether or not the research that you want to do is beneficial to them in enhancing their productivity or sustainability. On the regional level, usually it's more like long-sighted, like they're looking for advances in technology that's going to make cotton more productive or sustainable over the long term, like increasing or enhancing the way we harvest cotton, or maybe the way we breed or select for a new herbicide tolerance or something like that, the big picture sort of issues. But the state support is usually much more locally focused.
So
I guess I'll focus on Georgia. Each state, each region will have its own issues. In Georgia, you have this multi-year water war where I think it's Tennessee. So Tennessee and Florida and Alabama and Georgia are in a legal battle over who owns the water rights. The Flint River flows down and goes to, I think it's Apalachicola Bay in Florida, and there's a huge oyster industry there. Georgia wants the water from the Flint River and the aquifer associated with the Flint River for irrigation. Florida wants it for a huge oyster industry. So that, coupled with a few other water battles like between Atlanta and a part of Tennessee over some water that actually supports Atlanta, there's all these legal battles going on. So you have to find a way to produce as much cotton or as much crop as you can without upsetting all the other players in the game. So if you can increase efficiency, you help everyone out. And I think like 70% of water is used for agricultural purposes, but our population is growing, and it's not going to be a cotton producer that wins out in a water battle between a municipality like Atlanta. Like Atlanta will get that water if it needs it. So we need to work ahead and try to find ways to save water now when we're not being forced to, is the idea. So thinking ahead. Yeah. Well, here, one of the big issues is we get most of our, or virtually all of our irrigation water from the Mississippi alluvial aquifer. And it's a unique aquifer because it does recharge. It's at a certain rate, but we're still expected to run out of water. And our irrigation system historically here has been furrow irrigated, so you run water across the surface of the ground and it seeps in, but it's not really that efficient. So we have it's like something like 40 to 60% efficient. The rest of it either evaporates or runs off the field. Well, we have researchers here that have developed some new techniques on the way that they apply water and when they apply water. That has increased that somewhere between 60 and 80%, depending on the field, because each field here varies to some degree, and water and soil type and water infiltration will vary. So it's a difficult question to answer, but that coupled with different irrigation scheduling approaches like sensors and ET, so I know I forget y'all aren't in this field, but if you can calculate how much water is lost by the crop based on some of the environmental data we collect, like relative humidity, temperature, air movement, solar radiation, then you can replace just that amount of water, so you don't over irrigate. And there's also a lot of information that you can irrigate at a deficit, so less water than the crop actually lost, and still maintain high productivity. So you can balance out how much water you have and sort of maximize your profit based on how much you might actually yield less cotton overall, but your profit may end up being higher because you have less cost going in.
So basically, you're helping to the producers have their better profit as appropriate water level, but also it's connected with the sustainability aspect of the using water, right?
Well, if we continue to use the water at the rate that we're using right now, I forget when it is, but it's not going to be an option. So because the water level in our aquifer will drop too low. But again, this aquifer does regenerate, and they're even talking about directly injecting surface water back into the aquifer so that you can artificially recharge it. So we're very unique as far as our water problems here. It's not like the Ogallala. I don't know if y'all have come across that yet. The one out in the plains of the U.S. It doesn't recharge as fast, so they're just running out of water.
So water problem is
most producers here in Mississippi, they want to have their children be able to farm this land, and if we don't act as good stewards, then we're not going to have that option later down there. So we're doing everything we can to try to. We have a new water center opening actually that their goal is to address Mississippi's water issues in terms of production. So we're working on it, but yeah.
So I mean for the current industry to last for the next decades, we need to concern about this kind of water.
Yeah, water is our big issue, I would believe. Yeah, I mean there's a lot of issues, but that's the big one right now.